So to illustrate the pulse width adjustment technique, I have this setup here where I have two oscillators, so two instances of Sytrus, and I have both of them routed to their own wave candy so we can watch the waveform of the separate oscillators. And then I have a wave candy on the master so that we can watch the sum wave. And then also an equalizer so we can look at the harmonics. So here are a couple of basic things when it comes to adding and subtracting waveforms from each other. So here we have two sine waves that are perfectly in phase. And their sum is going to be this sine wave twice. So this added to this is going to equal this. So what would happen if I put this lower oscillator, so oscillator 2, out of phase with this first oscillator? So here in Sytrus, I'm in oscillator 2. This output knob can be used to invert the phase. So if I start turning it back to 12 o'clock, you can see the waveform getting weaker. And now it's off. And now it's in an inverted phase. So here you notice that nothing comes out. So this essentially means that I am subtracting this waveform from itself. So this would be like 1 minus 1 equals 0. So this output knob doesn't change the phase, it just flips it, so everything that is on the left side of 12 o'clock is going to be inverted, and everything that is on the right side is going to be the opposite phase. And this just adjusts its strength. So now what I'm going to do is I'm going to make the phase adjustable in real time. So here in operator 1, I'm going to go to phase. Then I'm going to route it to mod X. And I'm going to route it this way so it goes basically from full to 0 instead of this, because this is like, these are kind of like negative values. So it'll just, well, I'm going to show you what is going to happen if I do it this way. So it'll go to 0 in the middle, and then it'll go to the opposite side in the edge there. So I don't want it to do that. I want it to just go from the positive to the 0. So I'm going to put it here. Now that I adjust this, I can cancel the phase in real time. Also, another important thing to note is that a sine wave is just a single harmonic. So we can see here in the EQ that there's only a single harmonic playing. So now that this behavior is explained, what would happen if we change these to be saw waves? So I'm going to turn that into a saw, and I'm going to turn this into a saw, and I'm going to return this into the original setup for a little bit. So saw wave, arithmetic. Saw wave plus saw wave in the same phase equals 2 saw waves. So here's the interesting thing. So if we do the same exact thing to this saw wave, so we invert the phase, nothing comes out, then we link it to mod X and start adjusting it, what do you think will happen? You would probably think that it's going to do the same thing as the sine wave, like it's going to phase cancel slowly and then there's going to be nothing left. But here's the thing about saw waves. They're not symmetrical in the same way like a sine wave is, like that symmetrical arc on both the plus and the minus side. So the saw wave, so when I have an inverted saw wave, if I move the phase of this, it's like it's never gonna be in phase with this top one because like it's the wrong way around. Like even if I move this, it's never gonna be exactly the same as this top one. So here's the cool thing that happens if I do the real-time phase adjustment. So it turns into a square wave. So if we have two saw waves that are flipped and kind of like halfway through out of phase, I guess. And here when I talk about phase, I guess I'm talking about the vertical line where it flips into the negative side or the positive side. So you can see it's kind of like halfway there. And when we add two saw waves that are out of phase and flipped, it's going to result in a square wave. And when we adjust the phase of the oscillator 2 here, we can adjust the pulse width, like so. So why does this happen? Why does it become a square? Well, first we need to know what a saw wave is and what a square wave is in terms of harmonics. So here the equalizer is going to be very handy. So a singular saw wave consists of odd and even harmonics, and those harmonics are in a specific kind of configuration that is not necessarily important for this one, but just a saw wave is even and odd harmonics. But a square wave is only odd harmonics. I'm going to output just a saw wave. So you can see the harmonics right here. But now I'm going to add in the second oscillator. See what happens in the equalizer view? So all these even harmonics in between are canceled out when we have this phase configuration. So what happens when I move the phase of oscillator 2? It's going to kind of sweep through those harmonics, resulting in this sort of a pulse width adjustment.